April 1977, West Coast Computer Fair. Steve Wozniak and Steve Jobs unveil the Apple II. And it's not a kit. It's not a circuit board you have to assemble. It's a complete computer in a beige plastic case that looks like it belongs on a desk. Plug it into a TV and it just works. Color graphics, sound, built-in basic. This is the first computer that normal people can actually use. 4 years later, IBM, the most conservative, corporate, suit and tie company in tech, releases a personal computer. And suddenly, every business in America wants one. The IBM PC defines what a PC even is for the next 40 years. A year after that, Commodore releases a computer for $595, the Commodore 64, and suddenly, millions of kids who could never afford an Apple or IBM are learning to program, making games, becoming the generation that builds the internet. Meanwhile, in the background, Silicon Graphics is building workstations that cost $100,000 each. Pixar buys them, Industrial Light and Magic buys them, and suddenly Jurassic Park has photorealistic dinosaurs, and Toy Story becomes the first fully CGI movie. Hollywood has changed forever. And then Steve Jobs, kicked out of Apple, angry, determined to prove everyone wrong, builds the next computer. It's a commercial failure. Almost nobody buys it. But Tim Berners-Lee uses one to invent the World Wide Web. And when Apple brings Jobs back, Next becomes the foundation of macOS, iOS, and everything Apple builds for the next 30 years. These 5 computers changed everything. (1977) In a garage in Los Altos, California. If you wanted a computer, you had 2 options. Buy a kit, the Altair 8800, you'd get a box of parts in the mail, solder everything together yourself, and maybe it would work. These weren't computers for normal people. These were for hobbyists who understood circuit boards and could troubleshoot when things went wrong. Or, the second option, buy a terminal and connect to a mainframe somewhere. You'd rent time on a massive computer that lived in a corporate data center. Expensive, complicated, not yours. The idea that a normal person, not an engineer, not a programmer, could own a complete working computer in their home, that wasn't real yet. That was science fiction. And then Steve Wozniak builds the Apple II. So, Steve Wozniak was an engineer at HP, and he loved computers. He'd go to homebrew computer club meetings in Palo Alto where nerds would show off their latest kit builds and circuit board designs. But Wozniak wanted something different. He didn't want a kit you had to build. He didn't want a computer that only worked if you knew assembly language. He wanted a computer that just worked. So he built one. The Apple I was his first attempt, sold about 200 units, mostly to hobbyists. But the Apple II, that was the one that changed everything. The Apple II came fully assembled. You didn't need to solder anything. You plugged it into a TV and it worked. It had color graphics, 8 colors. When most computers still used monochrome text displays, it had sound. It had expansion slots so you could add peripherals. It had basic programming language built in. And here's the key. It came in a beige plastic case. It looked like a product, not a hobbyist project. You could put it on a desk in your living room and it wouldn't look out of place. Wozniak had created the first computer that normal people could actually use. But the Apple II doesn't become a massive success until 1979. That's when VisiCalc launches. VisiCalc is the first spreadsheet program, and it's only available on the Apple II. Suddenly, businesses have a reason to buy personal computers. Accountants can do calculations instantly instead of using ledgers and adding machines. Financial analysts can model scenarios. Small business owners can track expenses. Before VisiCalc, a business would spend $100,000 on a mainframe to do this kind of work. Now they can spend $2,000 on an Apple II and do it on their desk. VisiCalc sells 700,000 copies, and every single one of those sales means someone buying an Apple II to run it on. This is the moment personal computers stop being toys for hobbyists and start being serious business tools. The Apple II goes from interesting gadget to essential equipment. But Apple does something brilliant. They target schools. In 1978 till 1982, Apple heavily discounts the Apple II for schools. They donate computers to classrooms. They create educational software. They train teachers. The goal is simple. Get Apple IIs into schools and kids will grow up using Apple. They'll learn to program on Apple. They'll get comfortable with Apple. And when they grow up and start businesses, they'll buy Apple. It works. By the mid-1980s, the Apple II is in schools everywhere. Entire generations learn computer literacy on the Apple II. The Oregon Trail, Where in the World is Carmen Sandiego, logo programming, these become defining childhood memories. The Apple II doesn't just sell computers. It creates a generation of people who understand computers. The Apple II runs from 1977 to 1993. 16 years of production, over 6 million units sold, thousands of software titles, a massive ecosystem. It proves that normal people can own and use computers. It creates the home computing market. It establishes Apple as a major company. The revenue from Apple II sales funds the Macintosh development. And it shows something crucial. A computer doesn't need to be the most powerful or the most advanced. It needs to be accessible, easy to use, complete. Wozniak's genius wasn't just technical. It was understanding that computing belonged to everyone, not just engineers. The Apple II made that vision real. Without the Apple II, there's no home computing revolution. There's no IBM PC. There's no Microsoft. There's no personal computer industry as we know it. The Apple II made personal computing real. Everything else follows from that. August 12, 1981, IBM, the International Business Machines, the most conservative corporate blue suit company in the technology industry, releases a personal computer. This is weird. IBM makes mainframes, massive computers the size of rooms that cost millions of dollars and run entire corporations. IBM doesn't make products for consumers. They make products for data centers and enterprises. But by 1981, IBM has a problem. Apple is selling computers, Tandy is selling computers, Commodore is selling computers, and businesses are starting to buy them instead of IBM mainframes. IBM needs to get into personal computers fast, or they're going to lose the market entirely. The problem? IBM moves slowly. Everything IBM does goes through committees, testing, approval processes. Their normal product development takes years. They don't have years. Apple already owns the market. IBM needs a personal computer now. So IBM does something radical. They create a secret team, only 12 people, led by a guy named Don Estridge. And they give this team complete freedom. Build a personal computer in 12 months. Use off-the-shelf parts. Don't wait for IBM approval for every decision, just build it. This goes against everything IBM normally does. IBM usually designs custom components, controls the entire supply chain, keeps everything proprietary, but Estridge's team doesn't have time for that. So they go to Intel and buy their 8088 processor. Not the newest or fastest, but it's available and it's cheap. They design a motherboard that uses standard components anyone can buy. They create expansion slots so third parties can add hardware. And then they do something that changes everything. They need an operating system, but they don't have time to write one. So they license one from a tiny company in Seattle called Microsoft. Microsoft doesn't even have an operating system to sell them. Bill Gates buys one called QDOS from another company for $50,000, modifies it, and licenses it to IBM as PC-DOS. IBM gets their operating system. Microsoft keeps the rights to sell MS-DOS to anyone else who wants it. This deal makes Microsoft one of the most valuable companies in the world. The IBM PC launches August 12, 1981. Price: $1,565 for a basic model. It's not the most advanced computer on the market. It's not the cheapest. The Apple II has color graphics. The IBM PC is monochrome. The Commodore 64 costs less. The IBM PC isn't revolutionary technologically, but it has something no other personal computer has: IBM's name. IBM means serious business equipment, means corporate approved, and means safe. When a business manager needs to buy computers and justify it to executives, they can say it's IBM, and nobody questions it. There's a famous saying, nobody ever got fired for buying IBM, and it's true. It becomes the safe choice for businesses everywhere. Within 2 years, the IBM PC is the best-selling personal computer in America. But here's where it gets interesting. Because IBM used off-the-shelf parts and licensed MS-DOS from Microsoft instead of keeping it proprietary, other companies can build IBM compatibles. Compaq, Dell, Gateway, HP. They all start building computers that run MS-DOS and work with IBM PC software, and accidentally creates an open platform. They think they're selling computers. What they actually do is define a standard that everyone else copies. And here's what's insane about the IBM PC. The fundamental architecture is still what we use today. The Intel processor family started with the 8088 in the IBM PC, your modern Intel or AMD processor, still x86 compatible, still running code designed for that 1981 architecture. The expansion slot concept, well, came from the IBM PC, so modern PCI Express slots are direct descendants of those original expansion slots. The keyboard layout, that's basically the IBM PC keyboard. The 101 key layout became the standard everyone copied. Even the internal architecture, how the motherboard is laid out, how components communicate, follows patterns established by the IBM PC. This wasn't the most elegant design. It wasn't the most advanced, but it was good enough. It was open enough that others could build on it, and it had IBM's good thing. So it became the foundation of computing for decades. Apple went proprietary. You could only get Mac hardware from Apple. IBM went open. Anyone could build a PC. And in the long run, open won. The PC platform dominated because hundreds of companies competed to make it better and cheaper. Here's the irony. The IBM PC's success destroys IBM's dominance. Because IBM made the architecture open, clone manufacturers undercut them on price. Compaq, Dell, Gateway. They can build IBM compatibles cheaper than IBM can build their own computers. By the 1990s, IBM is struggling in the PC market. They eventually sell their PC division to Lenovo in 2005. The company that defined the PC exits the PC business entirely. But the standard they created, that lives on. Every Windows PC you can buy today is a descendant of that 1981 IBM PC. The architecture they defined became the foundation of modern computing. IBM wanted to dominate personal computers. What they actually did was create the platform that commoditized personal computers. They made computing open, competitive, and universal. The IBM PC's legacy isn't IBM's dominance. It's the fact that the PC became something bigger than any one company, a standard that everyone could build on. 1982. The Apple II cost $1,300. The IBM PC cost $1,565. These are expensive machines. For a middle-class family in 1982, that's a huge investment. Most people can't afford these computers. And that means most people can't learn to program, can't experiment with software, can't access this computing revolution that everyone's talking about. Well, personal computing is still mostly for businesses and upper-middle-class families who can afford Apple IIs for their kids. The revolution is happening, but it's exclusive. Then Commodore releases the Commodore 64. Price, $595, not $1,300, not $1,500, but $595, and sometimes even cheaper when retailers have sales. Suddenly, personal computing is accessible to normal families. Working-class families, kids whose parents would never spend $1,300 on a computer can convince them to spend $600. The Commodore 64 doesn't just sell computers, it democratizes computing. It brings the revolution to everyone. So, how does Commodore sell a computer for $595 when everyone else charges twice that? Because Commodore owns their entire supply chain. Most computer companies buy chips from other manufacturers. Expensive. Commodore owns MOS Technology, the semiconductor company that makes the chips. They manufacture everything in-house. They control costs in ways Apple and IBM can't, and they pass those savings to customers. The Commodore 64 has impressive specs for $595. It has 64 kilobytes of RAM, hence the name. Color graphics with 16 colors. The SID sound chip, one of the best audio chips ever put in a home computer, capable of amazing music and sound effects. Sprite graphics hardware, built-in basic programming language. This isn't a stripped-down budget computer. It's legitimately powerful. Game developers love it because the graphics and sound hardware let them create arcade-quality games. Programmers love it because 64 kilobytes of RAM is enough to do real work. The Commodore 64 proves you can make a powerful, capable computer affordable if you're smart about manufacturing. And then, the Commodore 64 becomes the gaming machine of the 1980s. Game developers figure out how to push the Commodore 64 to its limits. The SID chip produces music that sounds like nothing else. Listen to the music from games like The Last Ninja or Commando, and you'll hear why people still make SID chip music today. The Sprite hardware allows smooth, arcade-style gameplay. Games like Ghostbusters, Impossible Mission, Pit Stop 2, Summer Games, these defined gaming in the 1980s. The C64 has thousands of games. The library is massive, and here's the thing. Because the Commodore 64 is affordable, way more people own them. That means game developers can sell more copies. That means more games get made. That means the library keeps growing. The Commodore 64 creates a cycle. Affordable hardware means more users means more software, means more reasons to buy the hardware. It's the network effect in action. For millions of kids in the 1980s, the Commodore 64 is their introduction to gaming. It's where they play their first games, discover their favorite genres, start thinking about how games are made. But the C64 isn't just a gaming machine, it's a programming machine. When you turn on a Commodore 64, you don't get a desktop or a menu. You get a basic prompt, a blinking cursor. The computer is waiting for you to tell it what to do. The C64 manual includes basic programming tutorials. Type in these commands, see what happens. Magazines publish game code. You could type in hundreds of lines of basic, run it, and play a game. Kids learn programming by modifying these games, seeing what changes, breaking things, and figuring out how to fix them. The Commodore doesn't hide computing from you. It makes you a programmer whether you intend to be or not. You have to understand how computers work to use a Commodore 64. Entire generations of programmers started on the Commodore 64. They learned BASIC, then learned assembly language to make games run faster, then learned how the hardware worked at the lowest level. Many of the programmers who built the internet, who created the software industry of the 1990s and 2000s, started as kids playing with Commodore 64s. The C64 created the generation that built modern computing. And then there's the demo scene. Programmers in Europe especially started competing to see who could make the most impressive graphics and music demos on the C64. These weren't games, these were technical showcases. Scrolling text, 3D effects, synchronized music, graphics that supposedly weren't possible on the hardware. The demo scene pushed the C64 far beyond what Commodore engineers thought it could do. Programmers found tricks, exploited quirks in the hardware, wrote code that barely fit in 64 kilobytes of RAM, but produced results that looked like they needed 10 times the power. This wasn't just about showing off. This was hackers in the best sense. People understanding systems so deeply they could make them do impossible things. The demo scene taught an entire generation of programmers to optimize, to think creatively, to push limits. Many game developers, graphics engineers, and software architects started in the C64 demo scene. Even today, the C64 demo scene is still active. People still make new demos for 40-year-old hardware, still find new tricks, still compete to do the impossible. The Commodore 64 sells between 12.5 and 17 million units. Exact numbers are disputed, but it's massive. It's the best-selling single computer model of all time. Even today, no single computer model has outsold it. It runs from 1982 to 1994, 12 years of production. In the computer industry, that's an eternity. Most computer models last 2 or 3 years before being replaced. The C64 lasts because it's good enough and it's affordable. When competitors release newer, more advanced computers, they cost more. The C64 keeps getting cheaper. By the late 1980s, you can buy one for under $200. Commodore eventually screws up the follow-up. The Amiga is more advanced but more expensive and gets mismanaged. Commodore goes bankrupt in 1994. But the C64's legacy survives. It proved that computing could be for everyone, not just the wealthy. It showed that you could democratize technology by controlling costs. It created the generation of programmers and game developers who built the modern world. The Commodore 64 was a cultural phenomenon in the 80s. In Europe especially, the C64 defined 1980s computing culture. In the UK, Germany, Scandinavia, the C64 was everywhere. Whole subcultures formed around it. Gaming communities, demo scene parties, cracking groups, music composers. People still make music on SID chips. Still program games for the C64. Still hold demo competitions. The Commodore 64 has a retro computing community that rivals any platform because for millions of people, the C64 was their first computer, their introduction to technology, the machine that taught them computers could be creative, playful, powerful. The Commodore 64 democratized computing. It made the revolution accessible, and it created the generation that built everything that came after. But in the early 80s, if you want to create computer graphics, 3D models, realistic rendering, visual effects, you have two options. Option 1, mainframes. Massive, expensive computers that take hours or days to render a single frame. Lucas's Industrial Light and Magic uses them for Star Wars effects. Universities use them for research. They cost millions of dollars. Option 2, you don't. Most people simply can't access this technology. 3D computer graphics is something only massive corporations and universities can afford to experiment with. And then James Clark, a Stanford professor who worked on 3D graphics hardware, starts a company called Silicon Graphics, SGI. The goal, build workstations specifically designed for 3D graphics that are powerful enough to do real work, but small enough to fit on a desk. SGI doesn't make consumer computers. They make professional workstations that cost $50,000 to $100,000 each. These aren't for home users. These are for companies that need cutting-edge graphics power. But compared to million-dollar mainframes, SGI workstations are cheap. And compared to waiting days for a render, SGI workstations can render frames in minutes or even real-time for simple models. SGI brings high-end 3D graphics out of the mainframe era and onto desktops. And that changes everything. But in 1986, Steve Jobs buys a computer graphics division from Lucasfilm and turns it into Pixar. They need powerful computers to create their animated films. They buy SGI workstations. Pixar's first short films, Luxo Jr., Tintoy, are rendered on SGI machines. These films prove that computer animation can be emotionally compelling, not just technically impressive. And then Pixar starts working on Toy Story, the first fully computer animated feature film. Released in 1995, Toy Story is modeled and animated on SGI workstations, then rendered on a farm of 117 SunSpark Station 20s. Artists use SGI's running software like Alias and Wavefront to build characters and scenes. Then RenderMan processes each frame on the Sun Render Farm. This isn't just a milestone for Pixar, it's a milestone for computing. A feature film, 77 minutes long, thousands of shots, fully rendered CGI characters and environments, is created on Unix workstations that fit in a room, not a warehouse. Toy Story proves CGI animation is viable for feature films. It launches Pixar into what they become. And it shows Hollywood that SGI workstations are the future of animation. After Toy Story, every animation studio starts buying SGI workstations. DreamWorks, Blue Sky, Sony, everyone. If you want to make CGI animation, you need SGI. In early 90s, around 1993, Steven Spielberg is making Jurassic Park. He wants realistic graphics into his movie. ILM, Industrial Light and Magic, takes on the challenge. They use SGI workstations. Specifically, they use software called Softimage running on SGI hardware to model, animate, and render the dinosaurs. The T-Rex attack scene, the velociraptors in the kitchen, the brachiosaurus in the field. These are all CGI, created on SGI workstations. And they look real, not cartoonish, not obviously computer-generated, real enough that audiences believe they're seeing living dinosaurs. Jurassic Park proves that CGI can be photorealistic. It shows that computers can create visual effects indistinguishable from practical effects or animatronics. Before Jurassic Jurassic Park. CGI was mostly used for simple effects or cartoon-style animation. After Jurassic Park, CGI becomes the standard for blockbuster visual effects. ILM, weighted digital, digital domain, all the major VFX houses use SGI workstations through the 1990s and early 2000s. The Matrix, Titanic, the Lord of the Rings trilogy, Star Wars prequels, all created on SGI hardware. And then it doesn't just change movies, it changes video games. In the mid-90s, game developers start using SGI workstations to create 3D game graphics. Nintendo uses that technology as the foundation for the Nintendo 64. The console is literally named after Nintendo's partnership with Silicon Graphics. Game studios like Rare, Naughty Dog, and countless others use SGI workstations to model characters, design environments, and create textures for PlayStation and Nintendo 64 games. Games like GoldenEye, Banjo-Kazooie, Crash Bandicoot, Final Fantasy VII. The 3D models and environments are created on SGI workstations and then optimized for console hardware. SGI brings professional-grade 3D tools to game development. Before SGI, creating 3D game assets was incredibly difficult and limited. With SGI workstations, game artists have tools previously only available to Hollywood studios. The 3D gaming revolution of the mid-1990s. PlayStation, Nintendo 64, the transition from 2D sprites to 3D polygons, is enabled by SGI, making 3D graphics tools accessible to game developers. But the SGI's workstation's impact goes beyond entertainment. Medical imaging, MRI machines, CT scans, generates massive amounts of 3D data. Doctors need to visualize this data, rotate it, examine it from different angles. The SGI workstations make this possible. Engineering and design, automotive companies, architects, they use SGI workstations They can design cars and buildings in 3D, bringing professional 3D computing to industries that change people's lives. But in late 90s, SGI workstations start struggling. The problem? Their workstations cost $50,000 to $100,000. But PCs with NVIDIA and ATI graphics cards are getting really good, and they cost $2,000. SGI's advantage was specialized graphics hardware. But NVIDIA and ATI are making graphics cards for gamers, and the gaming market is massive, so these cards get better and cheaper fast. By 2000, a high-end PC with a good graphics card can do 90% of what an SGI workstation does for 5% of the price. For most users, that's good enough. Hollywood and major VFX studios keep using SGI for a while longer, but even they start transitioning to PC render farms. Pixar moves to Linux clusters. ILM transitions away from SGI. SGI files for bankruptcy in 2009. The company that revolutionized 3D graphics is gone. Their specialized hardware couldn't compete with commodity PCS running NVIDIA cards, but their legacy survives. Every 3D animated film, every CGI blockbuster, every video game with 3D graphics. These exist because SGI proved it was possible. They created the tools, the workflows, the industry standards. And here's what SGI workstations changed. They made 3D graphics accessible. Not accessible to consumers, they never made cheap computers, but accessible to creative professionals like animators, VFX artists, game developers, engineers, people who needed powerful 3D graphics but couldn't afford million-dollar mainframes. SGI created the industry of computer-generated imagery. They built the tools that built Pixar ILM, Weta Digital. They enabled the transition from practical effects to CGI. They made 3D gaming possible. Every CGI movie you watch, every 3D game you play, every advanced medical imaging technology. These exist because SGI workstations proved that desktop 3D graphics could be powerful enough for professional use. SGI workstations lost the market to commodity hardware, but they created the market in the first place. They showed what was possible, and that vision, that 3D graphics should be powerful, accessible, and visual, that vision defined an entire industry. In 1985, Steve Jobs is forced out of Apple. The company he co-founded, the company he built, pushes him out. The Apple board and CEO John Sculley decide they don't need him anymore. So he starts a new computer company. Next, the goal, build the most advanced, most beautiful computer ever made. Show Apple and the entire industry what they're missing. Next isn't about making cheap computers or competing with IBM clones. It's about building the perfect computer for universities and professionals. Price is secondary. Quality is everything. Jobs assembles a team of Apple engineers who follow him to Next. He designs a computer that's meant to be a work of art. In 1988, Next releases their first computer, sometimes called the Next Cube because it's shaped like a perfect black cube made of magnesium. It's gorgeous. Seriously, it's one of the most beautiful computers ever made. Minimalist design, elegant lines, perfect proportions. It looks like a piece of modern art. The specs are impressive. Motorola processor, 8 megabytes of RAM, 256 megabytes magneto-optical drive instead of a floppy. Next Step operating system, the most advanced OS of its time. The Next Step has features that won't appear in mainstream operating systems for years. Object-oriented programming frameworks, display PostScript for beautiful graphics, multitasking that actually works, built-in networking. Incredible development tools. The Next computer is designed for universities, researchers, developers. It's a workstation for serious computing work. The problem? It costs $6,500. Then you need a monitor. Add $2,000. Then peripherals. You're looking at close to $10,000 for a complete system. In 1988, that's insanely expensive for a personal computer. You can buy several IBM PC clones for that price. The Next computer is targeting a tiny market: wealthy universities, research labs, professionals who need the absolute best. But the Next computer doesn't sell well. Next projects selling 50,000 units in the first year. They sell about 400 computers. Universities can't afford them. Researchers buy cheaper alternatives. Even the target market thinks it's too expensive. And Next tries discounting to universities. Doesn't help much. They release a cheaper model, the Next Station, for $5,000. Still too expensive. By 1993, Next stops making hardware entirely. The company shifts to selling just NextStep, the operating system, hoping other manufacturers will adopt it. They don't. Next is a commercial failure. The company never makes money. Steve Jobs is burning through his personal fortune keeping it alive. Industry analysts call it a disaster. By every business metric, Next is a failure. Steve Jobs bet everything on building the perfect computer and the market rejected it. But here's where the story gets interesting. The World Wide Web. The foundation of modern internet was created on a Next because Next built the best development environment available. In 1993, Next stops making computers, but NextStep, the operating system and development environment, is brilliant. Developers who use it love it. ID Software, John Carmack and John Romero used NextStep to develop Doom and Quake. Carmack later says Next had the best development tools he'd ever used. Developers create apps with NextStep faster than on any other platform. The object-oriented frameworks, the interface builder, the development tools, it's years ahead of everything else. But Next can't convince hardware manufacturers to adopt NextStep. The OS is too different, too advanced. The industry isn't ready for it. In 1996, Apple is dying. The macOS is outdated. Apple has tried and failed multiple times to create a modern operating system. They're running out of time. Apple needs a new OS. They evaluate options, and they decide to buy Next for $429 million. This brings Steve Jobs back to Apple, but more importantly, it brings NextStep back. Apple takes NextStep, reworks it, adds the Mac interface, and releases it as Mac OS X in 2001. Mac OS X is NextStep. The core operating system, the development frameworks, the architecture, it's all Next. And Mac OS X becomes the foundation of everything Apple builds for the next 25 plus years. Mac OS, that's evolved NextStep. iOS, built on the same foundation as Mac OS X. iPad OS, Watch OS, TV OS, all descendants of NextStep. The iPhone runs on an operating system that traces directly back to the Next computer from 1988. The frameworks that developers use to build iOS apps, UIKit, Foundation, those are evolved Next frameworks. Every modern Apple product, every iPhone, every iPad, every Mac runs on technology that came from Next. The company that failed to sell computers became the foundation of the most valuable company in the world. But it's not just the OS, it's the development culture, Next's development tools, interface builder, project builder, the object-oriented frameworks. These defined how modern software is built. Xcode, Apple's development environment for iOS and Mac apps, is a direct descendant of Next's tools. The way iOS developers build apps, drag and drop interface design, object-oriented architecture, this all comes from Next. Modern app development, the entire iOS ecosystem, millions of apps, exists because Next figured out how to make building software faster and more intuitive. Steve Jobs didn't just bring an operating system to Apple, he brought a philosophy of software development, quality tools, elegant frameworks, developer experience matters. These Next principles became Apple's principles, and they changed how software is built. But here's the weird thing about Next. It was both a massive failure and an incredible success. As a computer company, total failure. Barely sold any hardware, never made money, shut down hardware production after 5 years. As a technology company, unbelievable success. Created the OS that powers billions of devices, enabled the World Wide Web, influenced modern software development. Next proves that commercial failure doesn't mean technological failure. Sometimes you're too early, sometimes the market isn't ready, sometimes the ideas are too advanced for the current moment. But if the ideas are good enough, they survive. They wait for the right moment, and then they change everything. Next didn't succeed by selling computers. Next succeeded by creating technology so good that when Apple desperately needed an operating system, they bought the entire company to get it. Steve Jobs spent 12 years in exile at Next, burning money, building technology that nobody wanted to buy. And then that technology became the foundation of Apple's resurrection and dominance. Next is proof that sometimes the most important innovations don't look like successes until years later. So, what you think? Drop your thoughts in the comments, and I'll see you in the next one.